I've got this lint roller that I'm going to use as a pendulum, and I'm going to hold it at its maximum amplitude. I'm going to leave my finger where it's maximum amplitude. When I release this pendulum, I can guarantee that it's never ever going to touch my finger again. And that might seem obvious because of air resistance, but let's go into the other uses of an effect like this. Before we do that, I'm going to quickly go and discuss two types of frequencies. The first is a natural frequency, and that is simply the oscillation of a system or particles due to vibrations or gravity, etc. And then you have a driving frequency, which is an external frequency provided artificially. So if I let this pendulum go, without air resistance, it would just keep oscillating at this sort of frequency. But if I were to add a driving force to it, you can see it will do something weird. And if I set the driving frequency such that it is equal to the natural frequency, a weird phenomenon called resonance occurs. What that is when the driving frequency matches the natural frequency, the system will oscillate at maximum amplitude. And at frequencies lower and higher than the driving frequency, the amplitude at which the system oscillates will be less. So if you plotted a graph of amplitude against the driving frequency, it may look something similar to that, where this peak here occurs at f0, where f0 is your natural frequency of the system. And this is important in certain real life scenarios. For example, when you're making a bridge, the bridge will have some sort of natural frequency to it. And if the driving frequency from wind matches a natural frequency, this bridge will start to oscillate at maximum amplitude. And there have been videos in the past you can search for resonance occurring on bridges and bridges actually collapsing. So ways to counter this is to use something called dampers. And what they will do is they will absorb energy from the system. And there are different types of dampers, such as heavy damping, light damping, and critical damping. This is an amplitude versus time graph of some naturally oscillating system. There's no dampers added in here. If I were to now add a light damper, it may change the graph to look something like this. The red line depicts light damping. You can see that this damper is causing the amplitude to decrease after each oscillation. And this is because it is taking out energy from the system. But notice how the time period of each oscillation is still the same. The time period is unaffected by damping. Heavy damping may look something like this. You can see that heavy damping is just a stronger version of light damping. It withdraws more energy from the system after each oscillation. And critical damping will look something like this. Here the energy of the system is completely removed after just one oscillation, so the amplitude falls immediately to zero. Now dampers are used in different things such as trampolines, etc. If the damper in a trampoline was too hard, you would end up jumping up and jumping back down and then ending up breaking your bones because too much energy would have been withdrawn from the system. You can also find dampers in your cars. If you were to push down on your bonnet, you'd notice that your car will go up and down and it should return to rest after about 1.5 oscillations. Now I said earlier about the bridge and what happens when the driving frequency of the wind matches the natural frequency of the bridge. The same thing happens for certain buildings and stuff as well. So what you can do is incorporate different materials into the bridge or into the building, and each material will have a different natural frequency. It will be much harder for the driving frequency of the wind to match each natural frequency of each material in the structure. So resonance would have been less likely to occur. Now, the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously, go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.